Good morning, guys. This is Trevor May, the Standard Air Lite in the VRF and the duct-free split technical specialist here. Back at you for another tech tip. This tech tip is going to be more focused on our new hybrid combinations in reference to the FV models, FB models, and FX models, and then also the integration of what we're currently seeing with the product line, which is going to be our gas furnace combinations. And of course, we're going to cover what's applicable and what is not applicable at the current time, and then also looking forward into future coil combinations that we can take and use in a multitude of residential style applications. So let's have a generic overview of what we're going to be looking at here. So our new hybrid combinations for 2021. So first, we'll start with the existing product line, which most, if not all of you, should be familiar with by now, which is the F model fan coils that we're pairing with our single zone outdoor units. And you can see here, this is going to consist of our FV4, our FX4, and our FB4, and of course the corresponding combination charts, which tells you the applicable match. In this case, the most important thing to note is that these are on the single zone units only. Now you'll also notice on here that these have the older 38 MAQ model numbers, the newer 38 MAR BQs, which are just essentially updated outdoor units with a little bit better performance ratings. Are applicable matches. They are also backwards compatible with any other ductless system. They are just new updated products. And currently the AHRI ratings are on the AHRI website. Now moving forward with the gas furnace combinations, this is essentially going to be the second stage and one that is currently out right now that we're working on getting product education to you guys. And then of course, making sure you have what you need to make this possible. So you'll see on here, this is going to be again with our single zone units only. In this case, it's going to be our 38 MAQs. And as I stated on the previous slide, the updated model number, of course, will be applied to these combination charts as Carrier decides to put out more literature for this. But for the time being, if we take a look at the entry tier comfort series, you can see we have the 59 and 58 SB, SCs, and then on the 92% furnace, the 59 SC2s. And on the 95% furnaces, we have the 59 SC5s on there, all of which are compatible with the single zone only ductless outdoor units. Now, as we get into the 80% and the 95%, the ultra low NOx models, you can see on there the 58 SUs and the 59 SUs are also compatible with the comfort series for our entry tier furnaces. Now we can also update and go to our mid-tier furnace combinations, which will be our 80 and 95% efficient models. The 58 TPs and the 58 TP6s on there are going to be compatible with our single zone outdoor units. Now, of course, as more models are updated on AHRI's website, of course, you can always access SEER ratings, HSPF ratings, COP ratings, all the technical information that your customers or that you guys may need. But as it stands right now, this is going to be our applicable matches currently with the entry tier and the mid-tier product line. Now, looking forward on here, we are going to start looking at case coils essentially as a drop-in over an existing third-party furnace, such as a Bryant, such as a Mana, depending on what the customer has. And of course, these aren't out yet, but these are the combinations that have been tested and approved with the single zone outdoor units for our multi-poise A coils and also our vertical N coils. Now, of course, you'll see there isn't really much diversity in this product line, just because we have so many other combinations such as gas furnaces, FV4s, traditional ductless indoor units. This is just one other tool that you might have depending on the application that may work for the customer as a direct coil replacement and not a furnace replacement itself. So let's take a look at how we're going to wire these up depending on whether we have an FV model or whether we're taking a gas furnace and a dual fuel setup with a ductless system. So with the FV, the FB, and the FX fan coils you'll see on here, this is what you're going to need to make this setup work. So you're going to need a 38 MAR single zone outdoor unit only, no multi-zones as it stands right now. We're going to need a 24-volt interface. We're going to need a 5-wire non-heat pump thermostat. So we need one that's programmable as a one heat, one cool. Of course, we're going to need our applicable FV, FB, or FX fan coil. And then, of course, because we have a hybrid combination, We have an EXV at our ductless outdoor unit, so that we need our TXV removal and piping adapter, which essentially is a male chetlet fitting that removes the TXV from that indoor unit so that we don't have a double pressure drop. In essence, this is what we need to make this FV, FB, and FX hybrid combination possible. So let's take a look at what we need to actually make it work for wiring wise. So what we have here, of course, you can see in the top right is our 24-volt interface, which we need to purchase separately with this. To the left, we can see our FV4C printed circuit board, and in the bottom center, our outdoor unit. And then right above where our FV4C indoor unit is, our 5-wire third-party thermostat. So let's start at the outdoor unit. So of course, we're going to have our power, our L1, L2, and signal feeding directly from the outdoor unit into the 24-volt interface. Now, it's important to note on here that you'll see where it says to outdoor unit, you need to make sure that you wire those wires appropriately and not to the one that says to indoor unit. Because if you do, you're going to get a communication interface between this interface itself and the outdoor unit. So we want to make sure that we wire that up to the appropriate terminals. Okay. One other thing to note on here as well is that the factory installed transformer that steps down our incoming power to 24 volts AC can be removed. All you have to do is unplug it right on the power lines, and then also, of course, the secondary side of the transformer. We're just going to go ahead and remove that. Guys usually ask, what are we supposed to do with it? I always tell guys just to keep it in case you ever need one. If you don't need it, you can always dispose of it as well. Okay, so we have our power coming from our outdoor unit, feeding up and powering our 24-volt interface to give it line voltage power, and also so that it can talk to the outdoor unit and display applicable codes, and also tell the outdoor unit, depending on what that indoor unit needs, whether it be a cooling call, a heating call, or a call for the fan. Okay, from there, let's go over to our FV4 printed circuit board. Now you'll see on here, this already has a step-down transformer, stepping down to 24 volts for control voltage. So what we're going to do in the field is we're going to take thermostat wire from R and C, and we're going to take that right out of the outlet of the transformer and wire that into the appropriate R and C terminals at the FV4 indoor unit. We then take those same R and C, or hot and common terminals, and feed them over to the 24-volt interface on the T-out1 and T-out2 terminals, which essentially is going to be the input for 24 volts for our 24-volt interface module to power our thermostat. So instead of using the interface to step down to 24 volts, we're taking 24 volts from our FV4 indoor unit. Okay, so we have power coming in and signal provided from the ductless outdoor to the interface. And then from our FV4 indoor unit, we're going to supply 24 volts AC from the FV4 to the 24-volt interface to supply 24-volt power for our thermostat. Okay, so now what we want to look at is our third-party thermostat. Typically, we see our Ecobee thermostats, which we sell here at Standard Air Lite, but it could be any 5-wire non-heat pump thermostat. Okay, now you have your R and your C, your hot and your common, which is going to feed up to CN15 on the 24-volt interface, which you can see depicted here in the wiring diagram. And then you have your Y, your W, and your G terminal. Of course, they're going to wire to their corresponding terminals. Y obviously is going to be our call for cooling, and W is going to be our call for heating. Okay. Now that signal is sent via the third-party thermostat into the interface, which then interprets that Y call or that W call, and then communicates that via the signal line to our outdoor unit to let it know that it has an active call for cooling and an active call for heating. Okay, now finally, we need to be able to focus on what's going to run our fan. Well, we want to look over to CN18 here, which has G1, G2, and G3 terminals. These are individual outputs for our fan speed. Now with the FV4, we only need to focus on one of them. So we don't want to wire G1, G2, and G3 all back to the G terminal at the FV4 printed circuit board because we'll cause a direct short, and of course nothing's going to work. What we need to wire up to is to terminal G1 from the 24-volt interface or on CN18 and wire it directly to G on the FV4C AHU or indoor unit. Okay, now what you'll see on here is when you have an active call for fan, this signal is going to be sent from the third-party thermostat into the interface, which then sends that signal on G1 to the G terminal at the FV4 printed circuit board, which essentially tells the fan to come on. Okay. Now, if we look at our FV4C printed circuit board, you'll see all that we have hooked up is R, G, and C. And that'll throw a lot of guys for a loop because you're used to seeing all your thermostat connections here. But you have to remember, we have a hybrid combination. We need to reference where our thermostat is up here and see that it hooks up to the 24-volt interface. So there are typical thermostat connections. We're only using a G terminal to broadcast a control signal to this printed circuit board to let the system know that there is a call for a fan, and this interface broadcasts that same signal on the signal wire that feeds to our ductless outdoor unit to energize or de-energize the reversing valve, depending on what mode that we're calling for. Okay, and last thing that we need to focus on is there is a supplied sensor that comes with this kit on CN5. You'll see this little T1 sensor on here. You need to make sure that you take this T1 sensor and the extension kit that comes with it. I believe it's up to 10 to 15 foot on there, that we can relocate this return air sensor into the return air boot on the actual furnace or the air handler itself. Make sure we can read return air temperature. If you don't relocate this temperature sensor in there, the system's not going to be able to read an accurate return air, and of course, we're not going to be able to control room temperature for what the customer wants. Okay, so in an overview, we're looking at a ductless outdoor unit that's powering up L1, L2, and providing a signal to the interface module. We have our 24-volt power, which is supplied from our FV4 printed circuit board from the transformer inside of here. So we're removing this transformer that comes with the interface. We have our 5-wire third-party thermostat set up as a 1 heat, 1 cool option, Y1 being the call for cooling, W1 being the call for heat. And then finally, we have our return air sensor that's going to be relocated to the return air boot of this furnace or this air handler. Okay, so now that we have the wiring set up on here, now we want to look at the printed circuit board of that FV4. And you can see here, I'll flip back to the previous slide, what we're looking at right here now is what you're actually going to see at the furnace. So this is where you're going to have an R, a C, and a G connector. Now we need to look at the easy select tabs on here to make sure that we have this set for the appropriate combination, depending on the tonnage of the unit, depending on the CFM adjust, depending on the on-off delay that we want, which is fully customizable. So if we have some form of auxiliary heat, we need to look at tab A on there and make sure that we set it to the appropriate KW that we have attached to the system. If we look at tab B, our AC heat pump size, the only thing to note on here is that if we have a 12,000 combination, the smallest tap that we have on there is a 018 for an 18,000 BTU. We just need to leave that on the 018 tap on the B terminal, which we see right here. Okay, everything else can be set for its corresponding temperature. If you have an 18, leave it on 18. If you have 24, put it on 24, 36, 36, etc. The system type, I always tell guys to select the heat pump comfort, but the heat pump efficiency is also an applicable match as well. Our AC heat pump CFM adjust, you can see here it says select nominal on there. Nominal is just to receive the AHRI ratings that these systems are rated at depending on the combination. You can adjust low or high depending on what the need of the space is. We have our on-off delay on here, which you can see is 090, 3090, or no delay at all. Typically the 090 is more than efficient enough, but if you want to change it for some odd reason, you do have that option. Our continuous fan speed on here, and this is the biggest thing that customers and also technicians seem to forget on here, is that these do operate just like any other ductless system where the fan will continuously run, unlike a traditional furnace where the fan comes on when the call is active and it shuts off usually a couple minutes after the call has went away. So these fans will continuously run. This tap will determine what that fan speed after a set point is going to do. Now you see the only rule on here for CFM is going to be for the 12,000 models. We need to make sure that we select medium continuous fan speed for those models. Everything larger than a 12,000 BTU can select between a low, medium, or high tap. Okay, and again, that's for after the set point is reached. The fan will continuously run, so we need to make sure that our customers understand that the fan is not going to shut off. We're going to continuously cycle that air. And this is what we'll be looking at when we actually open the unit up itself. So we can see on the right hand side, there are taps, depending on what size what CFM, what system type, what type of auxiliary as far as kW is concerned, and then also our thermostat connections that come from our 24-volt interface on here. Okay, so we'll see we have our R terminal, we have the W2 terminal on here. Now that's one thing that we didn't talk about. W2 terminal on here is that if we have auxiliary heat, which most of the time we typically do, what we want to do is we want to set these thermostats as a 2 heat, 1 cool option. So Y1 would be bring on the AC, W1 would be bring on the heat pump, and W2 would bring on the electric heat, and it would send that control signal directly to this W2 terminal from the thermostat. Okay, so the W2 terminal from the thermostat, when it's set up as a 2 heat, 1 cool option, you want to wire W2 directly to this easy select printed circuit board so that when that time comes that we need to kick on that backup electric heat, it'll send the control signal directly to this printed circuit board and the electric heat will come on. Now you can set the threshold of when the electric heat comes on and comes off from your third-party thermostat. Now, of course, each third-party thermostat is a little bit different as far as adjustable ranges that you can have between there, but typically about 2 to 3 degrees is usually what we see for a threshold when the heat pump's running and it's not keeping up when we need to kick on that electric heat during colder ambience. Okay, and then finally you can see on here you have your G terminal wired up, and that's coming from G1 from the 24-volt interface. This is going to be our male chatlet fitting that we need not only on the FB, and FXs, but also with our gas furnace combinations, because they are traditional residential units which have TXV in that indoor unit or in the coil, in the case coil, depending on what your pairing is. So we need to make sure that we have this male chatlet fitting to remove that TXV from the system, and then of course hook up the actual chatlet fitting itself to the distributor feeding into the indoor coil. If we do not, we're going to end up with a double pressure drop, and of course, as we all know, that system isn't going to work at all. Okay, so part number is below for that male chatlet fitting on there, and you can see on the one end of here that this is swedged out, essentially telling you that you either have to braze and or press on the system. Okay, brazing is allowed with this particular joint, and it kind of goes against everything that we've known with ductless, thus far. However, when you are brazing on the system, if that's what you so choose to do, you need to make sure that you are flowing nitrogen, at least 1 to 2 psi, just to try to displace any of that oxygen buildup in there, so we're not getting that scaling inside of the pipe, which of course can clog strainers, create restrictions, and cause system operation issues. So again, if you're not doing the press fittings, you need to make sure that when you are brazing, that you are flowing nitrogen. It doesn't have to be a ton, just 1 to 2 psi. And again, that should be something in your refrigeration process when you're doing brazing. That should be the ABCs of that is flowing nitrogen while brazing. Okay, so we talked about the FB4, the FBs, the FX models. Now let's look at the gas furnace combinations and what we need to make that possible. Okay, so now we still have our outdoor unit, which is single zone units only. We still can't do this with multi-zones as of now. We still need our 24-volt interface. We still need our indoor unit. In this case, now we've got a gas furnace. And of course, we want to check the applicable matches for the systems. We still need our TXV removal or our piping adapter. But now what's changed on here is that we need a single pole, single throw relay with a continuous duty coil. Of course, because we have that dual fuel operation between gas furnace and heat pump. And now we need a 6-wire thermostat set up as a heat pump because we have that dual fuel operation. We'll get into that wiring just a few minutes ago. But outdoor units, we have an outdoor unit, 24-volt interface, an applicable gas furnace, a TXV removable piping adapter, a single pole, single throw relay, and then a 6-wire heat pump thermostat. So let's look at that from a wiring perspective. So you'll see a lot of similarities on here with the actual FB models. Of course, we have our field supplied single pole double throw relay. So we need to make sure that we start at the outdoor unit. We have our L1, our L2, and our S terminal that feed directly out to the 24-volt interface so that the interface can send the control signals from the third-party thermostat to the outdoor unit to tell it whether it's got a call for heating or whether it's got a call for cooling. Okay. Now you'll see on here, just like we had with the FB models, the supplied transformer that steps down this line voltage to 24 volts AC is going to get removed, just like we did before. And we're going to supply that 24 volts from our gas furnace because we have a transformer that's already stepping down incoming voltage to control voltage, in this case 24 volts AC. So at the terminal connections for your thermostat at the indoor unit for your gas furnace, you're going to take your R and C, and you're going to feed that directly into these two terminals, just like we did with the FB4 model. So nothing's changed in that regard. We still have our L1, our L2, and our S terminal feeding from the outdoor to the 24 volt interface on the appropriate terminal, which in this case says to outdoor unit or CN11. And then we have our 24 volt power coming from our gas furnace feeding into terminals CN17 and 16 on the 24 volt interface, which are labeled as T out 1 and T out 2, so that we can supply 24 volts to power our thermostat. Okay, we look at our return air sensor that's still supplied with this. And all we're doing is the same exact thing. We're taking this return air sensor, we're putting it in the return air boot of the furnace so that we can read an accurate return air temperature and control the system properly. Okay, now the only difference on here is we're still taking G1, but instead of wiring it to the G terminal, we're wiring it to the Y terminal on the furnace. Okay, so it's important to note that G1 is being fed directly to Y on the furnace to energize that fan. Okay, the second change on here, of course, is going to be the fact that we're actually setting up this thermostat as a heat pump thermostat now, or a dual fuel thermostat. Okay, so you're still going to have your R and your C, so your hot and your common, coming from the thermostat, feeding into the 24 volt interface. But now we're going to take that O terminal and we're going to feed it through the continuous duty coil one, okay, which is going to feed back and feed back into the common. Okay, so now we have our Y terminal, which is going to feed out into this relay. And depending on the call, whether we have normally open or normally closed, is going to dictate whether we send that control signal to the Y terminal to turn on the cooling, or normally closed, or we send it to the W terminal to tell the system to turn on for heating. Okay, now you'll see with this single pole double throw relay on there, this is essentially how we're going to be able to differentiate between a cooling call and a heating call for the heat pump. Now you'll notice on here, we set this up as a dual fuel, and we have a W1 terminal right here. This W1 terminal comes directly from the thermostat and then feeds into the W terminal on the gas furnace. This is going to be the output for turning on the gas heat. And this is where that dual fuel operation comes in. Okay, and you can set this if you want the heat pump to shut off when it's 32 degrees outside and then kick over to the gas furnace. This is something that you can set up through your third-party thermostat, of course, depending on the thermostat that you're using. The factory does recommend, just because of how heat pumps deal with defrosting and downtimes with defrosting, that when the outdoor temperature is below 32 degrees, that you switch over and allow the thermostat to kick on the gas furnace while shutting the heat pump off, so we don't have to worry about any defrosting times. Okay, but again, that depends on what you guys, or how you guys want to run that system. But in essence, to make this work, we need that field supplied relay to be able to differentiate between a W1 call and a Y1 call. Okay, but again, we're using the O terminal to feed out instead of the W1 to the 24 volt interface. And again, that is a field supply relay. Okay, and now your W1 from the thermostat, when it's set up as a dual fuel operation, is going to be the output to turn on your gas furnace, just like any traditional system would be. Okay, so it could be a little bit confusing on how we're doing everything, but essentially the relay is going to allow the different changes depending on what mode that we need to be in. Send a control signal for cooling or for heating for the heat pump. Or are we going to send a control signal for heating directly to the gas furnace, depending on what system that we want to run. But in essence, aside from that field supplied relay and setting the thermostat up as a heat pump or a dual fuel thermostat, we're essentially doing the same thing as we did wiring wise with the FV4. The only difference is now we have a gas furnace versus electric heat, which we know is going to be a lot more efficient. So that's what I had for you guys. Hopefully you took something out of that. Hopefully you understand our hybrid combinations a little bit better as far as what's applicable, how to wire things up on a basic level. And of course, if you have any questions on anything, you're more than welcome to reach out to any of us here at Standard Air Lite Tech Support Department. You can always reach out to Product Manager Jamie McLumphy for Ductless, or for the VRF product line, you can always reach out to Rob Settle as well. And again, I always like to let you guys know I am your first point of contact. If for some odd reason I am out of office, or on vacation, whatever the circumstance may be, there are 3 other gentlemen that are more than happy to help you with any of your ductless or VRF needs. Their names and direct extensions are listed there. Again, if you guys have any questions on anything, please don't hesitate to reach out via my contact information, whether you call me directly at the office or just shoot me an email. I'm always here to help you, hopefully answer any questions and make your transition with these hybrid products as smooth and as easy as possible. So thank you guys for attending today. Again, hopefully you took something out of this, and I look forward to seeing you on the next time.